Right, so to start our 3 different presentations on Newton's laws, we're going to, of course, start with the first law. So what Newton's first law says is that an object at rest remains at rest, and an object in motion remains in motion at a constant speed in a straight line unless acted on by an unbalanced force. So basically what that means is if you have an object that's sitting still, unless some kind of force moves it, it's going to stay still. If you have an object that is in motion, it's going to keep moving at the same speed in the same direction unless there is something that causes that to change. So our objects at rest, we've learned about balanced forces and unbalanced forces. We said if the net force is 0, then that object is balanced, the forces are balanced, so that object should be sitting still. So if you have your computer just sitting on their table, the forces on it are balanced. There's nothing causing it to move because of a force being more than another. So unless you have an unbalanced force, that object's going to stay at rest. So unless someone comes and pushes your computer or pulls your computer, it's going to stay where it's at no matter what, unless there's a force there to cause that to happen. So until you have a push or a pull happen, that object's not going to start moving. Seems pretty logical. An object in motion is going to forever stay at the same velocity and direction unless there's some kind of unbalanced force that acts on it. So when objects are moving, let's say you kick a soccer ball, we had no friction, we had the ground not touching it whatsoever, where there's friction happening with the ground, that soccer ball would go straight in the line that you kicked it in and at the same speed forever. But of course we do have friction that slows it down. That's why we have air resistance and friction. That's why things slow down when we kick them, roll them, whatever the force is. But because friction and air resistance cause an unbalanced force, it causes that object to change its act in motion. So an example I like to give is bumper cars. So if you had a really giant bumper car rink and you had someone who was driving in a straight line, same speed the whole time, that car is not going to change if that person keeps their foot on the pedal, same rate, doesn't turn the wheel. It's going to keep going unless an outside force acts on it. And if another bumper car comes that hits it, then it's going to change its motion. So it's going to keep going the same way, same speed, unless something from the outside stops it. So if it weren't for friction, like I said with the ball, the objects would stay moving forever. It would never stop. The only reason that a soccer ball, when you kick it, slows down is because of friction. The only reason that when you throw a baseball with air resistance, that's a type of friction, that it doesn't go farther and keep going horizontally is because of friction. It is an unbalanced force that causes the object's motion to change. So it's hard for us to observe this because we're so used to it, it's everywhere, that just seems normal to us. So it's not as obvious as someone going and physically, stopping a ball with their foot as an outside force. But friction is always happening. So even though it's hard for us to kind of visualize, it is always a factor. This law can be called the law of inertia also. The definition of inertia is the tendency of all objects to resist any change in motion. So basically, it's exactly what the Newton's law is saying. With inertia, because of inertia, that object wants to stay still unless something else is pushing it, and an object wants to keep moving the same direction unless something else stops it. So unless there's going to be an outside force that acts on it, it's going to stay in the same spot or going the same speed and same direction depending on the unbalanced forces. And inertia is what causes that. And change based on the mass. It's going to change. So the bigger the object is, the more inertia an object has. So if it has more mass, it's going to have more inertia. So if you think about we had 2 vehicles next to each other. We have a semi and we have a Prius. Obviously, there's a large size difference between them. If you have them try to speed up to the exact same speed and start at the exact same time on the exact same road, that Prius is going to be able to get to that speed a lot more quickly. The reason that is because this Prius is smaller. It doesn't have as much inertia. Inertia is what keeps an object from changing its place. So when the car and the the car and the semi are at rest, they want to stay at rest, and inertia is what's keeping them there. So because that semi is so much bigger, that its inertia is really resisting it starting to move. The same thing happens if they were going the same speed and you told them to hit the brakes and see which one stopped more quickly. The Prius would stop more quickly because it has less inertia. As they start moving, then now the object wants to keep moving because that's what it's doing. Um, so when you try to make it slow down and make it come to a stop, inertia is going to make it resist that. So the semi, who is a lot bigger with more inertia, is going to resist the stopping a lot more extremely.